So this is question number 11. We're told that a function f is defined by f of x equal to ke to the power of x over 2 over 1 plus e to the power of x, where x is a real number and is greater than or equal to 0. The region enclosed by the graph of y equal to f of x, the x-axis and the y-axis, and the line x equal to ln of 16 is rotated 360 degrees about the y-axis to form a solid of revolution. Now in part A we're asked to show that the volume of the solid formed is this. Okay, so it's rotated about its x-axis, so you have to use this equation, right? Now limits are 0 to ln of 16. So if you substitute in ln of 16, if you substitute in y and square it, it will be k squared. Since k is a constant, I'll write that outside. E to the power of x over 2, and e to the power of x over 2 squared is simply e to the power of x. 1 plus e to the power of x squared dx. So now I'll use substitution, and I'll say 1 plus e to the power of x is equal to u, so du over dx is equal to e to the power of x. If you substitute in that, you get e to the power of x u squared, and then dx is simply du over ex. The dx cancels out, and the integral of u negative 2 is simply negative pi k squared, right? I think it should be u negative 1, right? Now I will substitute in u, so u is 1 over 1 plus e to the power of x, and then our upper limit is ln of 16, our lower limit is 0, so negative pi k squared of 1 over 1 plus e to the power of ln of 16, which is simply 16, and then minus 1 over 2, right, since 1 over 1 plus e to the power of 0 is simply 1 over 2. So negative pi k squared. I guess you can solve this using GDC, and you will get a value of, let me see if I've written the answer here. I believe I wrote it somewhere. Yeah, 15. You'll get a value of 15k squared over 15k squared pi over 34. Okay, so next part, we're asked to we're told that Pedro wants to make a small bowl with, let me paste it, with a volume of 300 cubic centimeters based on the results from part A. And so in part B we're asked to find the value of k. Right, so we found that this equation is the volume, so you can simply substitute in the volume, then 15k squared pi over 34. You can put this in numerical solver on your GDC, since this is a paper 2, and you will get a value of 14.7, if I'm not mistaken. Yeah, 14.7 for your k. So your k is 14.7. Now find OA. So this right here is OA, right? So we have to first find A. You can find it, so it's the y-intercept of f of x. So f of x. Okay, so this is f of x, right? So yeah, f of 0 is equal to 14.7 yeah, 14.7 e to the power of 0, which is 1 plus e to the power of 0, which is 2. So f of 0 is simply 7.35, right? So your OA is 7.35 centimeters. And as for your BC, well, we know that B, this line here, is at x equal to ln of 16. So you can substitute in f of ln of 16. I'm sorry, you can solve for ln of 16 by substituting in ln of 16 into f of x. And you will get a value of 3.46 centimeters. Now in part D, for design purposes, Pedro investigates how the cross-sectional area of the ball changes by sketching the graph of a suitable derivative of f. Find where the cross-sectional area of the ball is increasing most rapidly. Suitable derivative. So we're not given what kind of derivative they exactly want. I guess they want us to think, but it should tell us where the cross-sectional area of the radius of the ball is decreasing most rapidly. I guess for this you can use point of inflection, right? So when your double derivative is 0, you know that at that point your, let's say, dr over dt is a maximum. So you can use your GDC here for this part, and you can substitute in the double derivative of f of x. So perhaps it would have been a better choice if I would have opened my TI Inspire before recording this video. Okay. Anyways, so let me add a graph. So we know that this is our function. We want to find its double derivative. So I'll add the fraction, and then we know k is 14.7 e to the power of x over 2, then 1 plus e to the power of x. That should be fine. Was it not? Or did I make a mistake? Anyways, let's write the function first, and then we can take derivative easily. So 14.7 e to the power of x over 2, 1 plus e to the power of x. Oh shit, okay, I see where I made a mistake. This is natural log, not e. This is not natural log. What am I saying? It's Euler's number, right? So this is the f of x. Now we want to take its derivative, right? So, oh wait, I guess this is correct. Yeah, it is. Okay, so you can draw this graph, sketch it, and then using the 0, you can see that at 1.76 you have a point of inflection. And so this is the point where the graph of f prime of x the rate is rapidly decreasing. So if I check the marking of this, it should be correct, but just for the sake of making sure, yeah, 1.76. Or yeah, so this is the f double prime of x. Okay. And then in the final part, where is it? In the final part, we're asked to state the cross-sectional area of the ball at this point. Well, you can well, you have your point, so 1.76, and then you can go ahead and substitute in this value in f of x, right? So yeah, solve for f of 1.76, and you'll get the radius of the ball. Hope that helps.